Happy Thursday. I think today should be a national holiday. Opening day for baseball. National holiday, no one should have to work, but guess that's why I'm not in charge, right? We started looking at triple integrals last time, right? And we left off with a problem that was hideous and rectangular. So we integrated with respect to z first. We wrote as a iterated integral of a double with an integral with respect to z, and saw that, oh, well, that two-dimensional domain that we're left with is actually a polar region, right? And we described it in terms of polar coordinates, and that's where we left off. So how would we rewrite this integral now? All right, now it's going to be an iterated integral. How would we write it?
Be 0 to 2 pi, 0 to root 2, and then 4 minus 2 r squared. Dr under theta.
Everyone agree? See, told you. I'm going to go ahead and factor out a 2. And at the same time, integrate with respect to theta. Right? Because there's no theta in the integrand, and R does not depend on theta. I don't know why I just did that when I factored out that R, that 2. 2R minus R cubed dr. All right, we're going to have 4 pi. R squared from 0 to root 2 is just 2. Minus R to the 4th over 4 from 0 to root 2. Root 2 to the 4th is 4, isn't it? It'll just be minus 1. Volume of that solid is 4 pi. Uh-oh. Not only relate, you didn't bring breakfast today. Find the average value of y(e) to the negative xy over the rectangular prism 0 to 2 cross 0 to 3 cross 0 2. As a refresher, I'm going to just replace ds with dl, doesn't matter. Right, average value of a single variate function was 1 over the length of the interval times the integral over the interval of the function, right? And then dl is just the length differential, so for f of x it'd be dx. For 2 variate, there was 1 over the area of the domain times the integral over the domain of the function dA, right? So what do we think average value of a 3-variate is going to be?
Volume, with respect to the W,
Yeah, whatever the region happens to be.
triple integral of the region W, of the function f x, y, z, then easy.
Yeah, that's your average value for 3-variate. Which means if we had 4-variate, right, you just keep going. But remember, volume is itself a triple integral, right? You're just integrating over the domain with respect to the volume differential. So we need 1 over the volume of B times the integral over B of y e to the negative xy dv. What is the volume of a rectangular prism? Right? Width times height times depth. Length times width times height, same thing. Well, that's easy. 2 times 3 times 2. My volume is 12. That's nice. Now we need to set up our triple integral as an iterated integral. Which means we're going to need to choose an order. Make sure I did do it right in my notes. think I did. I just want to be safe. Why is it negative? This I did not. Wait, yes, I did. I just didn't simplify it. Okay. Perfect. The first differential should be obvious. The integrand doesn't depend on z. So that's going to be really easy to do. Now we have to decide, do we want to do dy dx or dx dy? We have a problem. If we do dy next, it's going to be integration by parts. If we do dx, the partial of negative xy with respect to x is negative y. We have a y. So the more convenient order would be to do dx and then dy. Integrate with respect to z. It's just the length, which is 2. Right? So we're going to be left with 1/6. We're going to need a negative, right? Integral 0 to 3. It's just going to be e to the negative xy, evaluated from 0 to 2 for x. All right, e to the negative 2y minus e to the 0. Antiderivative e to the negative 2y. Negative a half e to the negative 2y, right? That will be evaluated from 0 to 3. So it's what? E the negative 6 minus 1. that's just -3. Uh-oh. Oh no, I'm good. I'm still on track. Gonna factor out a -1/2. We factor -1/2 out of -3 with +6, right? E to -6 plus 5 all over 12, or if you don't like the negative exponent, one plus 5 e to the 6 all over 12 e to the 6. Integrating -1 with respect to y. And there's our average value. I'll get this sign in. And you walked in before the 15 minutes, so you won't be marked late. Questions on triple integrals. Gave you an easy one. Bless you. As with double integrals, where sometimes it's easier to integrate in polar, different coordinate system, and sometimes it's impossible to integrate in rectangular. You have to convert it. Same thing with triple integrals. There'll be those that you cannot do rectangularly. You have to convert. And then there are others that are going to be much easier to do if you convert. We will only look at converting to two coordinate systems for triple. The two that we studied, cylindrical and spherical. Again, you can convert to any, what do they call it, UVW, I think, coordinate system if you use a Jacobian. Sadly, we just don't have time to cover Jacobians. So again, it's essentially just a change of variable. We want to evaluate this iterated integral. Now we look at that and we go, huh, that just looks hideous. And in fact, if you try to evaluate it rectangularly, you're going to find you can't. 1 over the square root of x squared plus y squared plus z squared would have no analytic anti-partial derivative with respect to either y, z, or x. So even if you tried to rewrite this, you're going to run into the same problem. So we have to convert this. Well, double is easy because we only had the one coordinate system we were working with, polar. Triple, we now have to decide, do we want to convert it to cylindrical or do we want to convert it to spherical? Generally speaking, converting to both will make it doable. Actually, I think this one, we're going to find that one of them doesn't work. However, you will find that the ones where it doesn't matter, cylindrical or spherical, one of them is going to be easier. So we're going to plot this 3D region. Right? Don't want you. Let's just go in order. Y going to be between these two functions. Less than or equal to the square root of 49 minus x squared minus y squared. And next up was z. It's going to be between these two. Square root squared. And x was between 0 and 7. Even though I don't need x to go out to minus 10, oh wait, I already did x. Even though I don't need x to go out to minus 10, I'm going to have it go out that far anyway. Now, if I'm not mistaken, it's going to box this. It does. So let's turn off the box, set the origin. 0, 0, obviously label the axes. And let's turn off the mesh. Let's see what this gives us if I don't add any other options. Well, that didn't turn out as expected. Oh, that's interesting. Oh, that, okay, those are just holes. I don't know why they're there. I think if I adjust it. -7 to 7 all the way around, I should get rid of those holes. No, it still doesn't like it. What is going on? Whatever, just ignore those holes. We look at it. It's half a sphere, isn't it? Specifically, it's the front half. Have to find a really good angle. Show it. That should be good. Of course. Oh, that's right. Didn't save it as a JPEG. That's annoying. So we have to decide. Do we want cylindrical or spherical coordinates? Choice should be obvious. It's half a sphere, right? So we want spherical. Right, spherical ordered triple row theta phi. How would we describe row? So what would the bounds for row be? What did row measure in spherical coordinates? You don't remember spherical? Uh-oh. Not good. Rho is the distance from the origin to the point. So if we take any point in this region, what is it bounded by? And clearly at the origin, it's going to be 0, right? What if I pick a point on the surface? What would rho be? Goes out to 7, doesn't it? Theta. Theta is the same as polar. Take the projection of your point, call it P prime onto the XY plane. Theta is the angle that the ray OP prime makes with the positive X axis. We're looking at the front half of a sphere. That means X is non-negative. And Y can be anything. So what would the bounds for theta be in that situation? Think of the unit circle. Y is positive or negative, but X has to be non-negative. What quadrants are you working in? So what are the angles? Negative pi over 2 to pi over 2. right, this is a situation where I'm going to break with convention and not use 0 to 2 pi for theta, because that would require the setup of 2 integrals. B was the angle of declination. And it's the angle that the segment OP makes with respect to the positive z-axis. Well, z can be both positive and negative, right? So if we're going to take any point in here, it can range over that entire thing, can it? Right, so the ray is going to rotate through that entire thing. So what angles are phi going to go through? If we're somewhere on here, what's the angle of declination? Right, we're on the z-axis above the xy plane. Stay right there. By what angle is that ray declining? Yeah, right? On the z-axis, but now below the xy plane. By what angle does that ray decline? Pi, right? And we can be anywhere in between, right? As long as we're in the front. So phi can go 0 to pi. Which with enough recognition, you'd be able to get right from the setup. You wouldn't need the region plot. Right, you would recognize just from the bounds that this is the front half of a sphere of radius 7. I am not rewriting those bounds. I'm just going to say I for the integral. Now becomes the generally accepted order when converting to spherical is d rho, d phi, d theta. Again, by Fubini's theorem, that order doesn't matter, but for the most part, that's what I'm going to stick with. So outer bounds are for theta, oops, not 0 to 2 pi. Middle bounds are for phi. Outer bound or innermost bounds would then be rho. We now need to rewrite the integrand in terms of spherical. So what would that be in spherical? Just 1 over rho, right? Now, the volume differential when converted to spherical rho squared sine of phi, d rho, d phi, d theta. Do not forget that. All right, remember, polar gave you an additional r. Converting to spherical gives you an additional rho squared sine phi. Is there a theta anywhere in the integrand? No, right? What about bounds for rho and phi? Do rho and phi depend on theta at all? No. So we can just integrate with respect to theta, which is the length of the theta interval. That's just pi, isn't it? Since the bounds for rho are not dependent on phi, the bounds for phi are not dependent on rho, essentially we're working with a rectangle. We can just flip the order of integration without worrying too much, right? So we could integrate with respect to rho first, or with respect to phi, it does not matter. They're both pretty simple to do anyway. Rho squared over 2 from 0 to 7 would be 49 halves. All right, be left with 49 pi over 2 times the integral 0 to pi sine phi d phi. Antiderivative of sine phi is negative cosine phi from 0 to pi is 2. And we're left with 49 pi. That is another integral that is going to be used quite often. So you may want to make note. Right, save yourself some time. I think that was the second easiest problem in this problem set. We're going to integrate square root of x squared plus y squared over the solid bounded by z equals 1 minus x squared minus y squared and the xy plane. Really curious. Did Mathematica fix this issue? Let's find out. They did not. Perfect. Using plot 3D. If I alter the range, so I don't let it choose the range automatically, notice it gives me that ugly gray floor. I do not know a way around that. For this reason, I always use contour plot 3D. Even if it is written as a function of XY. What else do I want? Set the opacity 2.5. Beautiful. Set it a little tilted so we can see. What we're looking for. Right, the region that we're integrating over is inside this orange region that lies above the blue. Right, that's our region of integration. Of course you can't. I'm also going to do if we look straight down, right, in other words, we're setting Z to be 0. What's the curve of intersection? What kind of curve do we have? You don't have to be specific. You can just tell me what the shape is. The circle. Our solid has a circular base and height. That tells us we should be in cylindrical. I'm gonna write out the region real quick. All right, cylindrical is an order triple, R theta Z. It's actually a unit circle. So R goes 0 to 1. That means theta goes 0 to 2 pi. Z will go from the plane 0 up to whatever that R curve is, which is just 1 minus x squared minus y squared in cylindrical, which is 1 minus r squared. And this is where we'll pick up tomorrow.